Hello and welcome to Higher Maths, The Circle. We're going to look at lesson 1, the equation, one of the equations of a circle, so x minus a all squared plus y minus b all squared equals r squared. So a reminder, once we've completed the note, have a go at these questions from the Higher Maths textbook that you have. Full written solutions are here. Please check your solutions as you go, get in touch with me if need be. So the equation of a circle with centre AB and radius r is given by this formula. So remember, from the transformation of functions topic, x minus a all squared will move a curve, or in this case a circle, a to the right. And in a similar way, y minus b all squared will move the circle up by a height of b. Okay, so this is given in the exam. What I would suggest, guys, go on desmos.com and just type in x minus 3 all squared plus y minus 2 all squared equals 3 squared or equals 9, and then just change those numbers and just see what happens to the circle. You'll just notice it moving left and right or up and down, and as we change the r squared term, the radius will get smaller or larger depending on the values you pick. So desmos.com, just take 2 minutes to do that and just get a picture of what's happening. Okay, so for example, a circle with this centre and radius 4 has equation x minus 2 all squared plus y plus 1 all squared. So remember, if it's negative 1 here, it's y subtract negative 1. So y plus 1 all squared equals a radius squared, which is 16. If a circle had centre 0, 0, so if it has the origin as its centre, then x squared plus y squared equals r squared would represent the equation of the circle, because a and b are both 0. So let's have a look at an example. Find the equation of the circle with this centre and radius the square root of 3 units. So a is 1, b is negative 3, r is root 3, substitute in. Remember, if we're subtracting negative 3, we're just adding 3, so there's the equation of the circle. Root 3 all squared is 3. Question number 2. We're given points A and B. Find the equation of the circle which has AB as a diameter. So, as with any topic, if we can make a sketch of what we're being told, just to get a picture of what's actually happening. So, here's point A, here's point B. I know that represents a diameter, so I'm joining up points A and B and C for the centre, drawing a circle with that as a diameter. Okay, so I'm looking for point C, which is halfway between A and B. Centre of the circle will be halfway along the diameter. So I'm just going to step out like we were doing for the midpoint in the straight line section, in the straight line topic. So halfway between negative 3 and 5 will be 1, so that's a jump of 8, so I'm just jumping up by 4 to go halfway. Halfway between 1 and 3 is 2, so the centre will be at 1, 2. Now I would like to know the radius. I know the centre is at 1, 2. I know this point is at negative 3, 1, or this point's at 5, 3, whichever one I want to pick. So if I'm going from 1, 2 to 5, 3, I need to go 4 along, 1 up. So quick sketch, 4 squared plus 1 squared is 17. So the radius will be the square root of 17. Again, just applying a bit of Pythagoras there. So we've got the equation of the circle. We know the centre is 1, 2. We know the radius is root 17, so substitute in. And we have the equation of the circle. Testing a point to see if it lies within, out with, or on the circumference. Okay, so we're given the equation. Let's just have a look at this. We're given the equation of the circle here, or a circle I should say. Determine whether these 3 points lie within, out with, or on the circumference of the circle. So if we substitute in, and when we evaluate, if our value is smaller than the radius squared, then the point will lie within the circle. If it is equal to the radius squared, it will lie on the circumference. If when we substitute in, our value that we end up with is greater than r squared, the midpoint will lie out with or outside the circle. So 2, 1. So the x coordinate of 2, the y coordinate of 1 here, so x equals 2, y equals 1. Substitute in, so 2 minus 2 all squared plus 1 plus 5 all squared. So it'll be 36, which is greater than 29. Therefore 2, 1 lies out with the circle, outside the circle. 7, negative 3, substitute in. Evaluate, we end up with 29, which is equal to the radius squared. Therefore 7, negative 3 lies on the circumference of the circle. And the final point, 3, negative 4, again substitute in. Evaluate, we end up with 2, which is less than the radius squared, less than 29. Therefore 3, negative 4 lies within the circle. Okay, so just got those 3 tests to do there, just to find out if it's within, out with, or lying on the circumference of the circle. Okay, have a go at the questions I have selected from exercise 14a. As always, full written solutions are here. Please use them. Check your work, get in touch with me if need be.